By now, I hope everyone knows that chemistry is found everywhere. It's found in our bodies, the environment, and I'm going to talk about how it's even found in food. Well, in coffee. Why is coffee so popular? Well, it's popular because of its flavor, aroma, its stimulant effect, aka its caffeine content, and the benefits to human health. The roasting process is what contributes to all of these things. The coffee roasting process consists of 3 different stages: the drying stage, the browning stage, and the development stage. The first stage is the drying stage. In case you didn't know, coffee doesn't start out as the brown beans we know and love. They're actually green when they first arrive to be roasted. These green beans consist of 10 to 12% of water. Because of this, they need to be dried before they can be roasted. Heat is used to remove this excess water. After the beans have dried, the browning stage comes next. This involves the Maillard reaction. The Maillard reaction is a chemical reaction between amino acids and reducing sugars. A reducing sugar is a sugar that has a free aldehyde or ketone. These groups contain an oxygen atom with a double bond joining it to a carbon chain. These are important because they can easily react with amines or amino acids. When the reduced sugar and the amino acid react, they form glycosylamine, which continues to react to form metalloidians. These are how we get the flavors, aromas, and colors of different roasted coffee beans. The first crack is an indicator of the browning stage. This is when the coffee beans begin making a popping sound from being split open as a result of gases escaping the beans while they're expanding. They expand because of the heat. Lastly, coffee goes through the development stage. This comes after the first crack and lasts until the end of the roast. The length of this stage is what creates the different colors of roast: light, medium, and dark. Each roast has a different set of characteristics that contribute to their profile. Metalloidians continue to react with other smaller molecules to create the different flavors and odors of coffee. Here are some examples of those different aromas that occur from those different reactions. It's commonly known that coffee is a stimulant due to its caffeine content. We know that coffee comes in different color roasts, but could this influence its caffeine content? The longer the coffee beans are roasted, the smaller their volume becomes. During the roasting process, a coffee bean loses its mass. Coffee beans that are roasted longer are less dense because they lose so much of their water content. This means that darker roasted coffee beans are smaller and lighter than lighter roasted coffee beans. Light roasted coffee beans are roasted at lower temperatures for a shorter amount of time, making their volume greater, contributing to their density. Dark roasted coffee beans are less dense because of their longer duration in the developmental stage. This means higher temperature and longer roasting time. But let's say you measure out by weight 2 equal scoops of both colored coffee roast to brew. The darker roast will require more beans to match the weight of the light roast. Because of this, the dark roast will have more caffeine, but only because more beans are needed. Technically, both roasts have the same amount of caffeine content, but it's their densities that can vary this. So this means that no matter the color of the roast, they have about the same amount of caffeine content. Coffee is adored because of its flavor and caffeine, and now hopefully you have a better understanding of the chemistry that makes coffee coffee.